So welcome to the lecture 6 of the deep learning course. In this particular session, we are going to talk about perceptron. So what is perceptron? What is this new name? It will be clear to you very soon. And in this particular session, we are also going to see something that how you can train a perceptron. So you know that various models that we have seen earlier into the machine learning domain. So this is perceptron is also similar to that particular idea. It is also a model. So what is this? We are going to see in much detail today, and very simple concept, but it is a very important and initial concept for the neural networks to be studied. So let us start by seeing this thing with respect to a problem. Let's understand a problem and then try to find out its solution, and then we would be able to see that how come this perceptron fits in our understanding in that particular scenario. So I am bringing to you a problem that is not very new to you, and this problem is here with respect to this particular data. So try to see this particular data. In every row, you know that every row in any of your data machine learning data system represents something that is actually related to the features of that particular item. So this may be with respect to some item, and we are going to measure some of the properties, and those properties are being represented as a features. So in this particular setting, if this is the data, so this part represent the features, and the second part represent that what is the target value. Okay, so you can see here that two attributes are there, x1 and x2. What do they mean? What is their interpretation? Right now we are not very much interested in that. Let's assume that there is some item and we don't know that you can eat that particular item or not. Let's assume that you go to a new place where you find out a fruit, and whether you should eat that particular fruit or not, this is what the question is. So if you can eat that fruit, it's green, otherwise it's red. So you can also correlate this problem with this understanding that let's assume that when you are eating, it is sweet or not sweet. When it is sweet, you say that it is green. It is a green signal for you to eat. Otherwise, it is a red signal. Okay, and from outside you cannot find out that what is whether you should eat it or not. So you decided to measure some properties. So as we discussed that there are two properties. One property is x1 and another property is x2. How to measure that? Maybe one is weight, you find out the weight. X2 maybe what is the softness. This is the second thing. You also provide some number to that. Okay. So x1 says that what is one property, x2 says what is the second property. You pick any particular item, and for the learning purposes, you are into experiment, and therefore you are measuring these two properties, and you are actually eating it to find out that what is actually whether it should be green or red. So you created this particular table. Okay, let's assume by this mechanism you created this particular table. Here here just focus of any of them. For example, for this particular item, it was x1 value of x1 property was 2, value of x2 property was 5, and that item was not good for eating. This is the second item. X1 property was 8, x2 property was 5, it was good for eating. So in this way you created this particular table. Now we want to build a system so that if a new item is given to me, I can measure that what is its x1 and x2. Maybe x1 is 3, x2 is equal to say also 3, and I want to find out what should be the color. It should be should I say the green or red, or what kind of signal I should flash. So how can you go ahead to solve this particular problem? Very simple problem, machine learning problem. How can you solve this particular problem? To solve any of the machine learning problem, the first thing is always to visualize the data, understand the data, because if you can understand the data better, then you can represent and solve the problem. So how can we see this problem better? How can we visualize this problem better? So the first thing would be that looks like that since the data is into the two-dimensional only, so why not we should plot this data and try to understand that where the data points are. Okay, it's a two-dimensional data. You see that x1 and x2 two attributes are there. That's why it's a two-dimensional data. What if we plot it? So on one direction you say that x1, another direction you say that x2. So, okay. So what is the maximum value of x1? It is 10. So I can say that 5. Then I can say that till here 2. Then 1, 2, 3, 4. 1, 2, 3, 4, 5. Again, I can divide into the same way. So this is the 10. Okay. This is the value 10. On the y-axis also looks like that the maximum value is 10. So I can divide into the same way. So I can again draw these 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, let us plot the data point. The first is 1, 9. So 1 and 9. This is the data point. Okay. Then it is 10, 9. 10 and 9. I think 9 would also be on the same line. 10, 9. Then next is 4, 7. Next is 4, 7. So where is 4? 1, 2, 3, 4. 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, 6, 7. So I think 1, 2, 3, 4, 5 is here. So very easily we can plot it where. Third point is 4, 7. So 4 and 6, 7. This is the data point. So you do into this particular way. It is the next point is 4, 5. Where is the 4, 5? 4 and 5. This is the data point. This is the data point. Okay. But this data point is red this time. 4, 5. Okay. Next is 5, 3. 5 and 3. This is the data point. This is also red. Okay. 8, 9. 6, 7, 8 and 9. 8 and 9. This is the data point. 4, 2. 4 and 2. This is the data point. 2, 5. 2 and 5. This is the data point. 7, 1. 7 and 1. This is the data point. 2, 10. 2, 10. Okay. 8, 5. 8 and 5. This is the data point. 1, 2. 1, 2. This is the data point. 8, 2. 8, 2. Looks like this is the data point. All right, very good. So if you see this kind of data item, what comes in your mind? Looks like that all the negative items are one side, all the positive items are one side, because you say that these are the red items. So red items are looks like that into this particular area, and all the green items are into this particular area. Looks like that we can draw a line out of that, and that can separate this particular data item very efficiently. Looks like that if we can draw a line, then we can divide this data point into two parts, and everything above this line is actually uh, green, and everything below this line is actually red. So if somebody can tell me the equation of the line, I don't know that if somebody can tell me the equation of this line, how to find out that I'm not going to ask. I'm telling that somebody can tell me. If somebody can tell me this equation of the line, then I can neglect all these data points. Why the data points are needed? Because if this line is correct, then whatever, if you ask me that what is the classification of this item, I can put into this expression and I can find out that what is the classification. Then I no need to have this particular table. If somebody can tell me the equation of this particular line, then I don't need this table, because this table I have learned, and after that I can remove this particular table. Very important thing I'm going to tell, because equation of the line would only contain three parameters. Okay, you know that ax1 plus bx2 plus c. This is in this kind of line, equation of the line would be only of this particular kind. Then after that, and here if you want to store this thing into your memory or your database, how many values you need? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 multiplied by 3 values you have to store into the database. And here only 3 values suffices. And this is actually enough. This is actually enough to represent your thing. Because if you bring anything from here, I would be able to tell that what is the right classification of that. Then why you need to put this particular red over here? Understand? And even for the points which are not shown in my database, for them also I'm assuming that my system is correct based on this particular data. So any learning algorithm, any machine learning algorithm, when you develop it, it ends up in a summarization, and this summarization is going to be into the form of parameter, and that parameter are very less, and therefore we can say that it is a kind of uh, it is a kind of reducing the amount of information that you had. It is a compression. It is a compression. So if you are doing machine learning well, it means that you are having a good compression. Okay, you can see here this complete table, instead of this complete table, this particular equation is sufficient. All right. So this is an important concept that people talk about, that machine learning can be seen as a compression. How much compression you do uh, on the database. If uh, if two models are there, I'm giving a general idea to you. If two models we have, and one model is going to have the compression of 100, and another model is going to have the compression of 90, then which model is better? The model which does the most the compression. So this is again an important concept in the machine learning domain, that if you want to evaluate that how good your model is, then you see that how much it is going to compress your data. All right. So we were talking about that this was the data. We're talking about that this was the data. Looks like that this equation actually, this line, equation of the line actually can separate my data items. So this particular line is actually my model, and this is sufficient to describe the database. Okay. I don't know that how to find out this. We are very soon going to talk about that, how to find out this value. But if somebody can tell me, for example, 2x1 plus 3x2 minus 25 greater than 0 is the equation. Let's assume that somebody tell me that 2x1 plus 3x2 minus 25 is greater than 0 is that equation. What do I mean by that? That if you put into this equation 2x1 plus 3x2 minus 25, and you see the sign of this, if it is greater than 0, if it is positive, then you say the item is green, otherwise the item is red. This is what the simple equation is. If somebody told you how to find out this, we are going to talk about very soon. If somebody can tell you that this is the equation, then uh, your task is done. Let us try to understand that what is this equation is. If I pick any particular point, for example 4 2, whether this equation is right, 2 multiplied by 4 plus 3 multiplied by 2 minus 25. What is the value? Can you tell me? 8 minus 6, 8 plus 6 minus 25. So it is negative. So it is correct. This formula is in fact correct for all the data items. In fact, this formula is correct for all the data item. So this is the right formula. Okay, this is the right formula. Means this is the right formula. For this particular problem, once again, for this particular problem, this is the right formula. What does it mean? That if any item is coming to you, any new item is coming to you, for example, a item comes at this particular place, and it is maybe, I think it is 2 3. Let's assume the point is 2 3. So for this particular item, I measure that what is the value of x1? It is 2. What is the value of x2? It is 3. Using these things, if I want to find out that whether this item should be positive or negative, I put into this particular equation. Means what? I take this 2 and put it here. Again, I have taken 2 and 3 only, so it could be confusion. So it is 2 multiplied by 2 plus 3 multiplied by 3 minus 25. Can anybody solve for me? What is the value? What is the value? Yes. Can anybody find out the value for me? What is this value?
-12, sir.
Yeah, just type, that is fine. Okay, this is minus 12. Okay, this is minus 12, means it is a negative, means what, it is a red point. Okay, this is the classification. In this way we can find out the classification. Okay, what do I mean by this? Can I represent it in some way? So if I say that this value x1, I forget about this particular, what is the value, I can say that whatever this value is actually going to be multiplied by 2, whatever this value is going to be multiplied by 3. So on the arrow, if I write 2, means it is multiplied by 2. And then there is another value, that is coming to me, it is minus 25 because of this quantity. And I am going to find out the summation of this particular quantity, and then I am going to take it out, that what is the value, and I am going to measure, I am going to see that what is sign of this particular quantity. So whether I can make this particular kind of diagram, this diagram is also a representation of the same thing. It is also going to be the representation of the same thing, same equation. Yes or no? It is also going to represent the same thing. Whether this is the same thing, this diagram is same thing. Yes, this is the same thing, representation of the same concept. Okay, so let me draw it neatly, and it is also already drawn. The same thing is drawn over here. Okay, the same thing is drawn over here. Okay, okay. So this is a diagram where I am going to say the same thing. I say that instead of writing this expression, I am going to represent this expression with this equation with respect to a diagram. Okay, same thing. If you give me any item, I can find out that what is the value of x1, what is the value of x2. 2 and 3 are multiplied, minus 25 is subtracted. I find out the summation, and then I see that what is the sign. Based on the sign, I can say that it is positive or negative, 0 or 1, or green and red. I can tell it. This particular diagram has a name. This particular diagram has a name. What is the name? Perceptron. Okay, the name is perceptron. Now, hope you understood everything. I have a question for you. What is perceptron? The answer is, it is a representation of a linear decision boundary, because this was a linear decision boundary. So perceptron, what is the perceptron? It is a representation of the linear decision boundary. Correct? What is perceptron? It is a linear decision boundary. It represents a linear equation. Parameter of these equation, what are the parameter? 2, 3 and minus 25 are placed over the arrows. You may think, sir, you have put it here instead of having it on the line. Okay, minus 25, you can put it here and put 1 over here. This can also be a standard equivalent notation, so no problem in that. So this way you can say that what is perceptron? Perceptron is a linear decision boundary. Okay, perceptron is a linear decision boundary, and every perceptron, what do I mean by every perceptron? Depends upon the kind of problem, that how many attributes are there. If your problem, because in this particular setting your problem was having only two-dimensional data, two dimension. So if more attributes are there, it is a three-dimension thing. So you can say that x3, and there is also one more line, and this line would also have some parameter. I can say that p1. Okay, one more parameter. So if more input attributes are there, then more number of parameters would be there. How many parameters would be having? Equal to the number of attributes. So you can also again say that, sir, we had a few minutes back in our problem, how many attributes were there? Two attributes were there, x1 and x2, and but the parameter were 3. So to fix this particular problem, I say that always assume that there is one more parameter x0 and its value is 1. Okay. its value is 1 always. So whenever a table is given to you, whatever database table is given to you, you add one attribute from your side and put its value to be 1. And by this setting, what happens that this 25 shifts to here, and now everywhere you can say that all the parameters are on the link, and we are actually finding out their summation of what is the weights. We can say that these are the weights wi multiplied by xi, and it is a summation of all the xi. You are going to see find out this particular item at the summation, and then of course at the outside you want to see that what is the sign of this particular quantity. Clear? Any question till now? Any questions? Okay, so this was a simple thing. Okay, now important question comes that how to find out these values. What is these values and what they represent. For example, if instead of 2 3 I put 3 2, so will it be the same thing that will it give the same answer? No, it would not give the same answer, because if I change this 3 2, then equation becomes what the equation becomes. It is 3x1 plus 2x2 minus 25 is equal to 0, and this may be a different equation, and you are better you can find out that what is that particular value. Okay, you put the value of x1 is equal to 0 and see that at what point x2 is going to cut. You can draw this particular line, and I think we can also draw x1 if when x2 is equal to 0, then x1 is equal to minus 20 is 25 by 3. So x1 is 25 by 3 some value, and similarly you can find out what is x2 when x1 is equal to 0. It is 25 by 2. So you can see that this is line. That line is wrong. Okay. So these values are very important, and they actually plays a very significant role in finding out that what is this equation is. Okay. So let us quickly read this thing. This illustration is called the perceptron. You understand that what is the perceptron? It is linear decision boundary. It provides a graphical way to represent the linear boundary. The value 3, 2, and minus 25 are its parameter, are weights. Okay, how to find appropriate parameter is an important issue, and we are going to discuss it now. Any questions? Let us talk about that how to find out the right parameter. Now our task is to find out the right parameter. Okay. So there is an algorithm. That algorithm is a perceptron training rule. This algorithm we can utilize to find out the value of the weights. So it essentially says that how many weights we have. Okay. If I take this 25 over here, so how many weights we have? 3 weights. We can say that it is W0, it is W1, it is W2. I have to find out the value of W0, W1, W2. This we can represent as a finding out the sign of summation of for I, Wi, Xi that we have few minutes back seen, where this is the W0 and W value of W0 is always 1. This we understand. So we need the value of W0, W1 and W2. So algorithm says that you start with the random weights. You initially take random weight. I am not sure about this. Let me take 2, 5 and 8. Any random weight you can start. Then it says for each misclassified example. Oh my God, what is this misclassified example? So let us see that what is this equation is. This equation is 5x1 plus 8x2 plus 2. This is the equation. Okay, with these parameters, this is the equation. So these are the points to me. So if I put any particular point, for example, if I put this, let's assume that I am going to put this particular point 2 and 5. So what is the value? If I put 2 and 5, what is the value? If I put this is equal to 2 and this is equal to 5, so it is 10 plus 40 plus 2 becomes 52. The sign is positive. Okay, so the item is which item? 2 5 becomes what? Green. 2, 5, it becomes green. It is a green point. Is it a green point into the database? No, it is a red point. So there is a problem. Let me see another point, 1, 9. So if it is 1, 9, so it is 5 multiplied by 1 plus 8 multiplied by 9 plus 2. Again, it is a positive number, so it is green. Okay, so it is also green. It is green. So I am correct here. In the 2, 5, I was wrong. Here I was wrong. So some places you are correct and some places you are wrong. The algorithm says that the places where you are wrong, you find out what are the places where you are wrong. And you use this particular formula, Wi is equal Wi is equal to Wi plus eta time target minus output plus multiplied by xi. You use this particular formula to update the weight. You understood that not all the examples would be misclassified. Few of them would be misclassified into the previous. With this particular value itself, we have seen that green points are correct, but the red point are going to have the wrong classification. All the red point, because being this formula to be positive, all the weights to be positive, and all the points are also positive. So all the items are going to be given as a positive. So all the items are positive. Therefore, this all the negative point becomes wrongly classified. So algorithm says that for all the misclassified examples, you have to update using this particular formula. What is this particular formula? Let us once again investigate. The formula is Wi is equal to Wi plus eta time target minus output. Let me show what does it mean. Eta is a learning parameter. Earlier we have seen the similar kind of scenario into the previous classes where we were using alpha. Now I am going to say that it is eta, the same thing, a parameter. So this is going to be a small parameter. It is going to talk about what is the learning rate, means how fast you want to learn. What is target minus output? So let's assume again that green is equal to +1 and red is equal to -1. Let's assume that these are the, because if I want to subtract these values, I have to give them a numerical assignment. So let me say that green is equal to +1 and red is equal to -1. So since we have to only do this particular exercise when the items are misclassified, what could be the misclassified example? What is the target means what we want. Target is the right thing, okay? What is the output? Output of my system. So if the item is positive and it is a, what should be the output? +1. But if it is a misclassified example, then this value would be -1. Output is -1. For the misclassified example, if the target is -1, for the negative item, target would be output would be +1. Then only it is going to be misclassified. In this case, what is the value of target minus output? Can you tell me what is the value of target minus output? Target is +1, output is equal to 0, output is equal to -1. So this becomes 2. Am I right? Target minus output is 2. -1 +1, target minus output is -2. Okay. So this is what the scenario is. Target minus output is this particular quantity is positive. This particular quantity is positive when actually the item is positive. This is negative when actually the item is negative. Make sense? This quantity is positive when actually the item is positive. This quantity is negative when actually the item is negative. This expression, in this expression, you only have to focus on this particular part because all other things are positive. We as we have discussed in the previous session also, this particular expression, we can always make all the attribute to be positive without having any problem into my classification setting. Weights we are not interested in because their values are going to change. This eta is positive. So whether the weight is going to increase or decrease is only dependent upon this particular quantity, target minus output. So in the case you want a positive output, this quantity is positive, means the weight are increasing. In the case when the target value is negative, this is decreasing. Okay, this particular weight is decayed. Weights are increasing. Weight are increasing when your target is 1. Weight are decreasing when your target is -1. Okay, all right. So what is the effect? What is the overall effect of this increase or decrease? We have seen once again last and very important, and the only technical point that we have into this particular session is this: you are increasing the weight. You are increasing the weight means what? If you are positive, you are going to be more positive. If you are negative, you are going to be positive. You are going towards the positive side. If you are going toward positive side, what is your sign? What is your sign is going to be positive, plus V, positive. If you are increasing, means your sign is going to be positive side. If you are already positive and you are increasing the weight, because what is the equation? W0x1 plus W0x0 plus W1x1 plus W2x2. This is what the equation is. Whatever value you are going to have right now, if you increase the value of W, so what does it mean? That you are going to add, if you add delta to this particular W0, so it is delta plus x0 is being added to the previous value. If you are increasing something, say delta 2 to this particular W1, so delta 2 x2 is going to be added to the previous value. If you are also increasing the W2, so delta 2 delta 3, let's assume that you are going to add delta 3 to delta 2 to 3 to this particular W2, so this multiplied by x, I think x1, I should write x1. So this is the extra term that you are going to add to your previous computation. You are adding something to your thing, so things become positive. If this was negative, and this is all the positive thing because you are actually adding something. So if something was if some summation was there, then the summation is going to increase. Means if you were positive, you remains positive. If you were negative, you are going to be positive. Not definite. You are going towards the positive. Right now, you may not be immediately become from negative to positive, but if you keep increasing the value, after some time, your value would be positive. Whether this part is clear? If you are positive, you remain positive. If you are negative, you keep increase. If you multiple time you increase, you ultimately would become positive. If you are negative, yes, you are negative. Just focus on the second part. Yes, you are negative because it is a misclassified example for which you are changing. Yes, you are negative. That's why that is the problem. Your output is actually negative. So this particular change is going to affect your parameter in such a way so that you becomes positive, means your classification become correct. What happens into the second scenario? Into the second scenario, you actually decrease. Okay, we have seen that the parameter are decrease. Same effect happens, means this value becomes negative. Whatever amount you are decreasing, whatever amount you are going to decrease, that is going to reduce the summation, and therefore if you are already negative, then you become more negative. Okay, if you are positive, then you tends toward becoming negative. After some time you would become negative. Okay, if you do multiple iteration, sometime you would be negative. So for the positive item, just see, you were misclassified. You were giving the example positive, yes, because of the misclassification, you were that particular item was misclassified. So why was misclassified? Negative item was misclassified because your answer was positive. So in this particular scenario, positive value is going to be reduced and becomes negative. So definitely you are going to get the right parameters that are going to classify you correctly. So this is the
Sir,
understanding. Yeah.
so when the output output is negative, then we have to go towards the positive side, right? Or
No,
uh,
no. When the output is negative, let me tell you that when the output is negative, when the output is negative for the wrongly classified thing. If it is negative for the negative thing, we are not going to change this. For the negative thing, if the something your model is telling negative, then you have to go to the positive side, and this is happening because of target minus output is positive, and therefore you are going to increase the weights, and therefore your total summation is going to increase, and you are moving towards the becoming it positive. Make sense?
yes, sir. Okay.
So please note that I am going to do this for misclassified examples only. For the right examples, I am not going to touch. Okay. However, that we have seen into the previous classes also, because of this kind of changes, some right example also can become bad. But into next iteration, we would correct them. Okay. Provided the data is linearly separable. If the data is linearly separable, we would be able to find out the right parameter. So whether the intuition is clear to everybody? Any more question? Okay, we keep doing this update until all the training examples are correctly classified. And please also note, this misclassified set, it is going to change in every iteration. In the first iteration, these items were misclassified. Into the next iteration, other items would be misclassified. So this is going to change. This misclassified set is going to change. We are going to modify this. This strategy would converge. We have talked about that weight increase and decrease based on the weight and decrease that we have seen. That's why this strategy we think that is going to converge. However, the mathematical uh, modeling of the same problem we have seen earlier also, where weight was going to be modified, and we have seen that it is number of iterations required to make it correct is actually upper bounded. So this is a important algorithm. This algorithm have a name, and what is the name of this algorithm? Perceptron training rule. Okay, this algorithm has a name, and the name is the perceptron training rule. So if I ask you that what is the perceptron training rule, so you would be giving me this algorithm in the answer. Make sense? Okay. So this was the data that we had. This was the data that we had. Why don't we do a run? So you can write an algorithm. You by yourself, you are very good programmer. You can write into any programming language, you can write this thing. Okay. So let us assume that I have taken the value of eta 2 is 0.01, and I started with the w0. I started with the w0 is equal to 0.5, 0.5, 0.5, because I don't know what is the right value. I started with the 0, 1, 2 as these weights as a 0.5. And then what is the equation? Equation is going to be the positive equation. So where is the error? All the all the negative point 1, 2, 3, 4, 5, 6, 7, all the points would have error. So how many points I have an error? 7 point I have an error. Any questions on that? I would be having 7 points where the error is there. Then, as we have talked, that we have to change the parameter. Using what? Using the misclassified example, I am going to change the weights. So 7 update I have to do, not a single update. One update with this, one update with this. Every item is going to contribute into the update, and my weight is 7 times changing. After one iteration, when I saw all these items, my weights become this. My weights become this 0.3, 0.36, 0.12, 0.1. And with these change parameter, if you see that at how many places I have a error, the error is now at the 6 places. I was not able to correct all these things, but 6 places. Again, change the parameter, error becomes at 5 points. Again, change the parameter, error came to the 4 points. You can just write a C program that's take only 1 minute to write. Okay. Or maybe Python program that would even be easy. So error on 5 points. This is an interesting point. Try to note. Earlier error was on the 7 point, then it reduced to 6, then it reduced to 5, then it reduced to 4, but it again gone to 5. Why it happens? Because when I modified, maybe some positive points become negative and some negative point become positive, and number of points, 5 points become bad for me. Okay, but when I again modified the thing, it becomes again 4. Okay, it again becomes 4. Then again I modified, it becomes 5. Again I modified, it becomes 4. See what a problem. Okay, again I modified, it becomes 5. It becomes 5. Again I modified, it becomes 4. Again I modified from 4 to 5. See what is happening. But after this 5, after some time it becomes 3. Number of error becomes 3. Can you see this? After some time the number of errors becomes 3. Okay, let me take it below so that you can understand this. Okay, after that what happened? When I modified, it again become 4. Okay, then again become 3, 4, 3, then again remain 3, then becomes 2. Okay, points on which I had an error becomes 2. Then again remains at the 2. Okay, then after 14 more iterations, means I have done more iterations, 14 more iterations on this particular data. Actually I am doing all these things on this data only. After 14 more iteration, it becomes 1 error. But again it is not going to stop, becomes 2, 2, 3 again, fit 2. You can see that all these things are happening again. T2, from 1 it becomes 2, 2, 3, then 2, 2, and after that suddenly it becomes 0. How many iteration? If it was 14, 15, 16, 17, 18, 19, 20, 21. 21 iterations. I started with this particular value on this particular data. I was able to see that my error becomes 0. Any questions on that? You have to understand one very important point over here, that while updating the parameter, it is possible that your error is going to increase, because some point you are actually trying to correct, but other points may be wrong. So let me show you with a visualization here. So these were the points. Initially with the 0.5 we started. This was the line. If this is the line, then all the points are actually positive, and therefore the negative point becomes misclassified, and total number of points where error is 7. When I first time modified this, okay, the first time modified this is the line that I get. In this particular line, everything up is positive, below is negative, and these points are correct and other points are have problem. This was the 6-point error. Then I modified, this point becomes this, because you can see that if you want to make it correct, definitely it would move into this particular direction. So this happened, and the number of error becomes 5. Then what would happen? Where is the error? These 3 points and 2 points, definitely this point would move again into this particular side. This is the point, this is the line. With this new iteration, 4-point error, again 5-point error, because again it changes based on the errors. 5 point, 5 point, 3 point, 2 point, 3 point, 1 point, error on the 1 point, error on the 2 point, error on the 0 point. After doing this multiple number of time, you can see that this is the equation. This is the actual equation that actually we got. If you plot it on the space, you would be getting to this particular way. However, nice thing is it is not the best fit line. Best fit line would be a fat line that goes into this particular way. But for this particular data, this line also works. Okay, the my solution, whatever solution we have come up using this particular methodology, learning methodology is going to give me this particular line. Okay, this line is you can get by SVM. If you run the SVM, it is a fat margin classifier, then it would give you this line. However, my method is going to give you this line, and this line is equally valid for my data. No problem on that. Very important point is this, that error was sometime increasing and sometime decreasing, but ultimately it has reached to zero. My question is, why error reached to the zero? Are you sure that error would reach to the zero? My question is, are you sure that error would reach to the zero? Answer is yes, if you have seen the data. Since you know that your data is linearly separable, therefore definitely your things are going to be at the end. There exists a line, and you would be definitely reaching to the near to this particular line, and therefore your error would be zero. Yes, it is always possible because my data is linearly separable. That's why I know that my error is going to be, ultimately my error is going to be zero. Whatever time it takes to do the updation, at the end my error would be zero. So if I start by, if I start on this particular training scenario, if I start on this particular training scenario and I see that okay, my error is reducing and increasing, so I would not be worried about, okay, sometime your error is reducing, sometime error is increasing, so you would not be worried about, because you know that your data is at the end you are going to get the zero. Makes sense what I told you? That if you are sure, that if you know that your data is linearly separable and you are hunting for the right parameter, you are sure that at the end your error is going to be zero and you would be stopping at that particular time. But if you are not sure about this, that whether your data is linearly separable or not separable, you have not seen that, because it may also be possible that if the data is into the very high dimensional area, if it is a 4-dimensional, 5-dimension, then you cannot plot it and see. Then you are not sure that whether there would be a hyperplane that divides the data into two parts or not. So in that particular scenario, you are not sure that there would be sometime error is zero. So when you are into this particular scenario, when sometime your error is reducing, sometime is increasing, you would not be able to sure that where to stop. So let's assume that the minimum error is 1. In that particular scenario, let's assume the minimum error is 1. So when you reach this particular point, what is the indication that you should stop training yourself? This is the best parameter. Once again, what I told you, if the data is not linearly separable, then your minimum error may be minimum. Then the best parameter is going to give you error on 30 points, for example. But how do you know that 30 on the 30 point I would be doing the error? This you can only know if you have the parameters. So while training, where to stop you don't know. You don't know where to stop for the cases when when the data is not linearly separable. You are not sure that where to stop. What indication I get at this particular moment when I have the number of errors as 1? Should I stop at this particular place or not? So this is the biggest problem with this kind of algorithm, that if the data is not linearly separable, then you don't have the indication where to stop. And most of the time my data is not linearly separable, and this is the challenge that we have to take up, that how to build a system that can tell me that you stop at this particular point. And let me give you the idea also, that how can you do that. This value should monotonically decrease. Okay, every time this should decrease. So what I would do, that after some time, if I see that initially my error was reducing with a large thing, but after that my error is reducing with a very small value, so looks like that I'm going to be very near to the my actual values, and uh, looks like that. Let's assume that your learning curve is like this. What does it mean? That initially your error was reducing very fast, but after that your error start reducing very less. So looks like that it is going to be meet you at the zero, at the infinite. and you don't have infinite amount of time, so you stop at this particular moment, and you say that okay, I'm okay with that. So this kind of curve I need. This kind of curve has a property that monotonically decreasing. The value should monotonically, number of errors should monotonically decrease. What to do for that, you will see into the next class. Any questions on that? So this is a wonderful method by which you can find out the right parameter. But only issue is this that. But the only issue is this. Okay, what is this? But only issue is this that you are not sure that where to stop, and that's why you have to go for some other technique.